And we're back with another PicoCTF challenge, this time vault-door-7. Description: this vault uses bit shifts to convert a password string into an array of integers. Hurry, blah blah blah, source code is here. So I've already downloaded the source code, and we'll take a look at it in VS Code. If you've seen any of the prior vault series, you know that the main method just takes some input and then it passes it to check password. So check password is what we're really interested in. We see this helpful comment. Each character can be represented as a byte value using its ASCII encoding. Each byte contains 8 bits and an int contains 32 bits. So we can pack 4 bytes into a single int, which makes sense. Here's an example. If the hex string is, actually this is just a string, this is a typo. If the string is 01AB, oh no it's not, I see what they're doing. I see what they're doing. Then these bytes are represented in binary as the following, and we can see that they end up being put into a single integer here. So they're packing, if you see the highlighted. So these are bytes being concatenated onto each other and then being interpreted as an integer. And it's this very large, I don't know if that's 800 million, 8 billion, something like that. So since 4 chars can be represented in one int, the 32 character password can be represented as an array of 8 ints. Okay, cool. And as we look at check password, what we can see is we're looking for 32 bytes of input. Then we run this method on it that we see above that seems to be doing some shifting. And then we check to make sure that everything that we passed in matches this flag that we're seeing as these values. So the easiest way to approach this is, first, we already have some code that will do the encryption for us, or taking the password to an int array. So let's try to leverage that. I'll create a new Java class called vault-7 solution. And I'll create a main method, and we are going to grab that code. We're going to take a quick look at it, and then we're going to try to use it in our own code. So as we look at it, what we can see is we take a string, and we get the bytes, and we call that hex bytes, and we expect there to be 8 of these. So we're going from 32 bytes, and as we said, we can pack them with 4 bytes in each integer. So to loop over our entire input, we just have to loop until we hit 8, and we're doing some shifting. So what this is doing is it's taking something that is small. So you might have, let's give an example. This string of bits, if you were to shift this 2, then the 1 would be here, and zeros fill in behind it. So by shifting things, we can make it fit into those series of 8 placeholders in the int. So that's what it's doing. So it's shifting one of them 24, one of the hex bytes by 24, the next one by 16, the next one by 8, and then the final one it just places in. And now we have a packed int. So a nice thing to do would be, first let's try this function out. And to do so, I'm going to make this a static method. That's just a Java thing to make this a little nicer to use. So I'm going to pass in, we want 32 characters, so I'm going to pass in please, that is 6, sub. So we will do that 4 times. So please sub, please sub, please sub. Thank you very much. And then we are going to take that int array, and we'll call this packed ints. I like that. And we will print off one of these guys, and we'll set a breakpoint just to take a look at it. And now we're going to debug into it. And what we can see over here is we have our packed ints, and we know that this first one must be probably the PLEA in please sub, and then we get the next 4. And that loops. You can see how it's the same for 0, the 0 index, the 2 index, the 4 index, which makes sense. All right, so now let's try decoding this. And to decode this, we are going to have to take something like this value and then call a decrypt function that we're going to write. I can't spell decrypt, or unpack. Unpack is better. This is not really encrypted. Unpack int. And let's pass that guy that we think is PLEA. And we are going to create a new method. And in order to get it, so right now it's represented as an integer. We want to see what the bytes are though. and specifically the bits. So let's look at what we have with regard to that. So I'm looking at the available methods that seem byte related. So reverse bytes. Now to binary string, yeah, that seems interesting, and we could have read more in the Java docs, but I've already done this once, so I can tell you this is a good one. And this gives us a binary string. So let's say bin string equals this, and let's print it out. And we're just kind of working interactively with the system and debugging and setting breakpoints and doing all that good stuff. So we've seen this already. We're no longer interested in it. And let's reset the debugger. And let's go down here. And we can see we have a nice long representation where it's probably 32 bits. So let's go into our console and let's start interacting with this. And we want to grab off, because we know this is shifted, we want to grab off the different groups of 8. So to do so, let's do bin str dot substring. Oops, substring. And we'll go from 0 to 7, which is actually 8 characters because it's inclusive of the 0. And let's see what that looks like. And that looks like it could be maybe please, the P in please. So we've got that now, but we need to represent it as an integer and then ultimately an ASCII character. So let's try to parse it. We'll use integer.parseInt, and we will tell it that it's base 2. So we're taking this value, which is the string you just saw up above, and we are saying this, we'd like this as an integer. It's in base 2, and we get 112. Okay, and now let's say we were to cast it to a char, which is just looking it up in an ASCII table and saying, hey, we have a number. Does this mean anything in a common way of representing letters? And we can see it is a P, which is what we'd hope for. So this is good. So now what we need to do is we have an int, right? So we have 4 of these that are packed. So we need to take the next one. So the one starting at 8 and going to 15. So that's the next group of 8 bits. And we expect this to be the L. And we can see it is the L. So let's begin to build this out in here. So we'll call this string unpacked equals an empty string. Oops, sorry. And we will apply this operation to all of them. So we're going to do unpacked plus equals. So that just means take what was in unpacked, add this onto it, and then set it. I should show you, actually, I'm sorry. I'll show you, and then I'll do the shortcut. So this is a shortcut for doing this. So the prior value of unpacked, so an empty string initially, plus the P in this case, then becomes this variable. So we will do the shortcut, and we'll do plus equals. And we'll do this for our 4 values. So we said from 8 to 15, from 16 to 23, and then from 24 to 31. And then we want to return our unpacked string. And you can see it complains because our declaration above says this is a void method, meaning it returns nothing. So we just need to tell it we're going to return a string. All right, cool. So now we're going to have a string unpacked, which is going to be PLEA, we think. So let's verify that this works. Set a breakpoint here. I'll remove my prior breakpoint, and I'll run this through. And you can see we've hit our breakpoint down here, and we're really curious what is unpacked. And we can see it is PLEA. So awesome, this is working well. Let's jump right to our potential solution, or our flag. So we have this guy, and we want to know what are all these integers? What is the flag when we unpack it? So let's begin to try that. So we'll define our int array of packed ints now to be this guy, and I'm going to show you a nice shorthand to kind of clean this up. So we've got all this, and this is not what we want. We want just a basic array. Now you could do a multi-cursor, and you could do it like this, and that would be perfectly fine. But I'd like to show you, oops, wrong type of curly, sorry, wrong type of brace. I'd like to show you a way to do it with regular expressions. And I'd like to explain why regular expressions are cool through this example. So we're interested in matching all of this stuff and getting rid of it and putting a comma in its place. So, okay, easy enough. You can see as things match, I put in a space, I put in an X, I put in a left bracket, but now we get to a number. And you can see if I put in a 1, I only select the 1. If I put in the 2, the 3, how can I select any number that comes next? I don't have a good way unless I use regular expressions. And regular expressions are a richer way to search, and they come with a few downsides. So one thing you'll notice is we no longer match on the left bracket. Well, we have to escape it because it has a special meaning in regular expressions. So now we get to the reason we're interested in regular expressions. Now we have a way to match on any number, any single number. So we'll do a /d, which is the code for a number, then a / right bracket, a space, 2 equals, another space. And so we've matched everything we're interested in, and we're going to replace it all with a comma. And now obviously this is kind of a short example, so you don't really see how useful this can be, but if you had hundreds or thousands of lines, you would not want to edit it using a multi-line or anything like that. You would want to do something like this. So now we have our flag in the packed ints. So what I would like to do is I would like to loop over for each packed int. I'd like to unpack it, unpack I, and then let's create a string called flag, and we'll set it to be an empty string to start, and then we'll print it out at the end. And we need to do that plus equals that I talked about, where we'll add on all of our output. So let's run this. We'll go to this point, and we'll debug, and we'll see what this gets us. For some reason, I can't step in. Let's see. It's kind of weird, but all right, so we'll just run through to the end. And we will step out. Sorry, debugger's kind of acting a little goofy here. I'm not really sure why. Yeah, I'm not entirely sure. I'm going to let this run through. Something goofy is going on with the debugger. But this happens. Okay, so we get a string index out of bounds exception. And the reason this is happening, if you look at the individual bytes, oh, I didn't think, okay, that's nice. I'm printing things off. You can see these first 6 or so, they all seem to be the same length, and they all seem to have succeeded. This is line 25 that's printing off the binary string. But then we get to this one that's shorter than all the rest. Why is it shorter? Well, it has a leading 0, and a leading 0 is not meaningful in terms of a number. So if you're used to, say, base 10, our normal counting system of decimal, you normally write like 100 as 100, right? You don't write 0, 0, 0, 0, 100. You just write the first meaningful bit or the first meaningful number, and then you go from there. So if you were to write 10, again, you wouldn't write all this. You just write 10. Well, it's the exact same with the computer. What it's saying is, I have this binary string. I probably should have given you something that wasn't zeros and ones. So like 80, for example, just because zeros and ones looks like binary. You would not put a leading 0 for 80. You would just write 80. The exact same thing's happening here. We have a leading 0, and so we need to fix that. And the way that we're going to true that up is we are going to look at the length, and we'll left pad things, meaning we'll add zeros in front of this based on how much we need. So we'll say left padding needed equals, and let's find out what length is working. I'm going to just a second. I want my debugger back. Little mistake on my part. I stopped it. So I just want to know how long are these ones that are working. So I'm going to ask what the length is, and the length is 31. So we will say it needs to be 31, and if bin string that length is 31, then we don't need any left padding, right? It's exactly correct. If it's 30 though, the difference will be 1, and that's the amount of padding we need. So we will do a loop, and while left padding is greater than 0, so meaning we need left padding, we are going to first, just as a good practice, we will decrement left padding because we're doing a loop and we don't want to do this forever. So let's establish our loop condition, and we are going to say bin string equals 0 plus bin string. So we just add a 0, a leading 0. We subtract 1 from the amount of left padding we need because we've added 1 now, and we continue. So let's give this a shot now. We're going to rerun this, and we'll see. the flag comes out, a bit of bit shifting DC10. Let's submit this, and let's see if we succeeded. And we did. Hopefully that was helpful to you. If it was, you can help me out by leaving a like, subscribe, or a comment. I guess by liking, subscribing, or commenting. That's English. There we go. English is hard. Bye.